Hi, I'm Tom Hollands. I work at Spatial Vision. I'd like to give you a short presentation on Mapillary. I did some R&D for it as part of the Spatial Vision cadetship program last year. So first of all, I'll just give a bit of description of what Mapillary is. I'll look at what research questions I had when I started out. I'll show a bit of a case study that I developed, and then just some reflections on the whole process and what Mapillary is and what it can do for you. So, what is Mapillary? In a phrase, it's crowdsourced Street View. If you talk about Google Maps and OpenStreetMap, it's very much a similar relationship between Google Street View and Mapillary. The idea is that people will submit their own photos and they can create these Street View-like environments with their own images. So, in actuality, what that means is that it's made up of an image database. There's an API that can be accessed by developers to make applications. Then there's the apps themselves, a mobile and desktop application for collecting photos and posting them online, and a JavaScript library to make viewers in web pages for the images. So in terms of commercial offerings, Mapillary licensing starts at about $250 a month. Those professional licenses, obviously it's free for the public to join, but they can't they can't be used for commercial purposes. If you need private image repositories to keep your images safe, they start at $500 a month. And of course there are customized applications as well. But we'll talk about some of the customized applications that you can build later. So, how is value built on this basic idea of open source Street View? The first is just the model itself, crowdsourcing. Basically, you can collect images when, where, and how you like. You don't have this freedom with Google. Obviously, you're constrained by every one of their schedules and the things that they're interested in taking images of. But Mapillary does some really interesting things about actually generating information from the images themselves. So you can actually improve the information you have about the images through their computer vision and their technology that they've developed around structure from motion and things like that. So the process, essentially we have our Mapillary contributor over here. This could be anyone from the public. There are lots of people in the public who do this. Some post prodigious amounts of images up into the hundreds of thousands, even in an individual month's period. Basically what happens is the contributor over here takes a photo, they use the uploader in the app, there are also some Python libraries, and then the images go through this process of image processing, and this includes things like blurring, street sign detection, image segmentation and tagging, which I'll discuss a little sooner. And then we have the photo database here, which is obviously where all the information sits. How that is accessed is through a RESTful API, and their own applications are built on top of this API. So you can use the Explorer, you can use the mobile application, uses this API to access the photo database, but then also you can obviously use your own web technologies through this API to get access to the database, and this is where you get all of the development power from Mapillary. So in terms of where the company's going at this point, they have a large focus on this image processing and RESTful API development. So they're really pushing the idea of this developing the images into something more than just the images themselves by getting information from them, and the API so that third-party applications can be developed directly on top of the platform. I'll just go through a few of these image detection features. We can see here they have an extensive street sign detection library. So each one of these points here on the map is actually a photo that's been taken and it's had a street sign identified in it. You can obviously imagine the potential for this in things like asset management and things like that. But basically what happens is it'll take a photo like this and it'll use their optical recognition software to match up from a library of signs to the signs that it sees in the image. And that'll actually generate the geographical information for anybody to use. All of this information can be accessed through the API. One other really exciting feature is this semantic image segmentation. So basically what this is Mapillary run a computer vision lab in Austria, I believe it's Austria. And what they do is this semantic image segmentation is basically, you can see here, this image has been separated out into a series of categories, and these categories represent real life kind of categories of objects. So you can see here there's a person category, a road category, a sidewalk category, and as this animation runs here, we can see that different areas are being highlighted. It's because these highlighted areas have actually been identified without human intervention by a computer to represent real world sort of categories. This is obviously incredibly powerful and has lots of implications for just generating vast amounts of information without having to even look over it with a human eye. And while they haven't rolled this out everywhere yet, it's something that is really exciting on the horizon. So this other feature, structure from motion, which is very much part and parcel together with the image segmentation and detection of features and things. But basically what this allows them to do is create transitions between each of the photos so that you can create a full immersive environment by moving from one photo to another. And this is generated on every single one of their photos, and so whenever you upload an image to Mapillary, this structure from motion information is created without you having to do anything, and you can actually just build these environments just by going out and taking a few photos. So this time machine is something else they offer. As time goes by, obviously there are millions and millions of photos online already, but in 5-10 years time there's going to be millions and millions more, often probably at the same location. And what this time machine lets you do is it detects photos nearby that are facing in a similar direction, and what it'll do is it'll create this transition between the two images. And they have this little interface in the web application that allows you to directly compare these, so you can get a nice little time machine view. This is obviously very useful for things like anything that requires noting for change over time. If you're an environmentalist or something like that, or if you need to see what conditions are like, this is a good example. Across seasons, you can get that information through this little interface. So that's just a bit of an introduction to Mapillary, some of the features it offers. But what I really was interested in here with this research was to look at how it could be used for application development, how it could be used by Spatial Vision. So I wanted to look at what features could be added to applications, and I wanted to look at how much that would cost to the client, both financially and technically. And I wanted to try and kind of evaluate exactly how much Mapillary functions actually bring to an application. What value do they add? So I developed this case study. The premise is basically that Street View-like applications are really good for navigating. They're fantastic. They give the user a first-person perspective, a really high level of immersion, so they can get amongst all these images and navigate it like in a similar way to how they would navigate the real world. Obviously, services like Google Street View, they only provide imagery of public areas. There's a really good chance that if you have an interest in an area that is slightly off the beaten track, it will not be covered by Google Street View. So obviously Mapillary doesn't have that restriction, because you can upload photos at any geographic coordinate in the world, in Antarctica, on top of a mountain, on a rooftop. And these Street View immersive environments can be created literally anywhere. So this case study, the use case is our building needs some maintenance. And I am, say, a maintenance organizer. Maybe I work for the building, maybe I work for a third-party company, but what I want is my crew to be able to go and see the site before they get there. I want them to do an assessment of all the assets. I want them to know where they're going. I want them to be aware of safety hazards, all this sort of thing, before they even arrive. Obviously, I can't do that with Google Street View. They don't take photos of people's rooftops. But I don't have that restriction as a user of Mapillary, and I can take photos whatever I want. Go. So this is the proof of concept application. Basically what we have here is a Mapillary viewer window, and we have a map window over here. I've used some aerial imagery as the base map, just so we've got a bit more zoom level there. And I've populated it with some assets and also some wall features there. So in terms of the use case, we can see here that whilst this aerial image is not very good, we've got the assets mapped out here. And for example, if I needed to work on an air conditioner, I could view this photo. If we view this image, we can see that the air conditioners are here and easily viewable. The resolution is not very high on these images, but you can imagine if it was a lot higher, we could even see model numbers and things like that. We can completely plan ahead. We can see what our routes are going to be moving around the environment here using the map window and also the immersive imagery. And it will really just smooth out the whole process. This is a simple example because there's not a lot of information on this rooftop, but there are obviously really complex applications that could be built with this. So, a few reflections. Overall results from the research and the case studies reveal that the out-of-the-box functions are really good, really powerful. The API is super accessible, it's very flexible, and any unsupported functions which I did encounter can be developed very easily on top of the API in JavaScript. One thing I did notice is that data quality from users varies quite a lot. With so many images uploaded, there's really just no span for anyone to go through and validate every single one. There are often photos that people have taken on their dashboards that are pointing at the sky, all sorts of things like that. I think that most of the value from using technology like this relies in creating your own data. While the crowdsourcing model is very good, it doesn't necessarily produce the kind of imagery that may be useful. On top of this, development options are somewhat limited by the API. Specifically, there is no way to submit images to Mapillary without using an approved application at this point. But that's something I'm very excited to see in the future because it will allow the full range of development to happen on top of that. So bearing these things in mind, looking at all the really good features of Mapillary and some of the perhaps some of the still developing features, if I had to pick one line to describe it, it would be something along the lines of, it's a young platform, but it has a lot of development potential. And it's really exciting to see people working in open areas that have been dominated by big companies for so long. So, Mapillary, try it out.